volumes by washes. Consider two functions f and g whose graphs are given here, y equal f of x, and a second function, let's say y equal g of x. And we consider the region between these two curves from a value x equal to a here to x equal to b, let's say here. And we rotate this region R about a horizontal line y equal m, doesn't matter, y equal 2, 3, whatever it may be. So we will rotate this region about this horizontal line here. Of course, what we get is a solid of revolution, and we are interested in finding the volume of this solid. Well, the way you need to think about this is consider a point x like this, anywhere from A to B, and then we will call this distance, like from this line, the axis of rotation, to the graph of y equal f of x. This is capital R, and it depends on x, so we'll call it R of x. And the distance from the axis of rotation to the function g, we will call it small r of x, like this. Well, this big R is called the outer radius, and the small r is actually the inner radius of this solid of revolution. Now, with all of this, we can actually write the formula for the volume. The volume will be from the integral from A to B, pi r of x squared, so the outer radius, minus the inner radius, again squared dx. And that is actually the volume of this solid. Now, here is an example. The function y equal x squared and the function y equal square root of x are graphed here. The region between them is this one, and this region is rotated about the line y equal minus 1. Okay, here's the line y equal to minus 1. So our region is rotated around this line here. Okay, so I want to find the volume. To find the volume, of course, I need four quantities. I need to find what is the A, what is the B, what is the outer radius r of x, and what is the inner radius r of x. So these are the four quantities that we need to determine to find the volume. Okay, to find A and B, to find A and B, well, because A and B are the intersection of the two curves, then we need to solve x squared equal to square root of x. And by solving this simple equation, we will find that x is equal to 0 or x equal to 1. So a is 0. Yeah, so this is the a and this is the b. Now I need to determine the outer radius r of x. For this I need to focus a little bit on my graph here. So the outer radius is this distance r of x here, which is basically the 1 plus the function square root of x. This is square root of x. So r, yeah, the outer radius is 1 plus square root of x. And the inner radius, small r, is basically the distance from this to the lower curve here. And in this case, it's basically 1 plus the x squared. So 1 plus x squared. So small r, 1 plus x squared. Once I have this, then of course I can now write the volume. So the volume will be the integral from 0 to 1 pi the outer radius 1 plus square root of x squared minus the inner radius squared dx. Now pi can come out of the integral and we will get the integral from 0 to 1, and we can open these brackets, so it will be 1 plus 2 square root of x plus x minus 1 minus 2x squared plus plus x to the power of 4, all of this dx, yeah, like this, and then it will be pi. If we carry out the integration, of course the 1 and the 1 will cancel. 2 square root of x, integrate this, square root of x is x to the power of half, so integrate that. We will get 2 over 3 x to the power of 3 over 2, like this, plus the integral, so that's done. The integral of x will be half of x squared, and then minus 2x squared, we integrate that, so it will be minus 2 over 3 x to the power of 3, and finally the minus x to the power of 4, integrate that, we get minus x power 5 over 5 from 0 to 1. And of course at 0, all of this is 0, and we put x equal 1 in this expression, and the final answer, 29 pi over 30, is the volume we are looking for.